We talked about what it means to be a polynomial. We talked about how to add and subtract polynomials. We talked about like terms, right? Okay. So today we're going to talk about multiplying. So let me show you how to, before we multiply polynomials, let me show you how to multiply terms first. Remind me, what is a term? Give me an example of a term, Christian. 5x. Zaya, give me an example of another term. 3x. Give me an exponent on it. 3x squared. Do we all agree these are both terms? So when I multiply terms, all right, remember we did those properties of exponents? Yes, with the foldable, you just had a test on it. Properties of exponents. When you multiply with the same base, you do what with the exponents? You add them, right. That's properties of exponents. So whenever I multiply these terms, what do I do? Keep the base the same. You multiply the what? The 5 and the 3. That's exactly right. You're right. That's the coefficients. And then I have x, and what happens with the exponents? I have one exponent of 1 and one exponent of 2. What happens? You add them. It's 3. Okay? Now, let's just be clear, because I don't want you starting to get confused. When you multiply terms, you multiply coefficients. And you add exponents. Okay? Now remember, a couple days ago we added like terms, and so just to refresh you, when we add like terms, first of all, what are like terms?
Same base.
Same base and the same exponent. So give me an example of two like terms. 5x to the second and 6x squared. I'm going to give you a second to catch up with me, and then we'll finish. If I stuck a plus sign in the middle of these two, tell me what you do. Add what? The 5 and 6. And what happens with the x squared? It stays the same, okay? So don't start getting confused. Take that hood off, Gavin. Don't start getting confused with the multiplying versus the adding and subtracting, okay? All right. Start combining exponents is when you're multiplying. Then you can't combine them. Remember, we have to look for those like terms. We look for the ones that have the same exponent and the same variable. Yes, Gavin?
So, for multiplying, you only add the coefficients and the exponents.
You multiply the coefficients, not add, but you add the
Oh,
exponents.
yeah, multiply the coefficients. And then for adding, you only add the coefficients and keep some exponents.
Correct. Correct. It's okay. All right. Now, let me show you. Let's say, guys, y'all keep your focus here. Okay? Let's say I have 2x to the third times 7x to the fifth. What do I do? Multiply, right? Multiply how? What's being multiplied? Multiply the coefficients so you get 14, and then add the exponents, okay? Now, let's take it up a notch, because I said multiply polynomials, not just multiply terms, right? What if I had something like this 2x to the third? Actually, let's make it a different one. Let's make it 3x to the second. And I needed to multiply that to 5x to the third plus 6x.
You said it.
All right.
Like you said, it's 30.
You said it.
Inside first and then?
You can't combine anything. There are no like terms.
Oh,
But you said the right thing, but you said instead of, but that is actually what you're supposed to do. Distribute. You distribute. This is a distribute problem, right?
Yeah.
We've talked about doing things like this. How do you distribute? So look, I take what's on the outside, right? And it needs to go inside here. So what is 3x to the second power times 5x to the third power? 15x to the 5. So you multiply the numbers in front and you add the exponents, right? All right. But it has to go to both. It's got to go to the first one and the second one. So then I take it here. What happens? 18, right? Because there's an imaginary 1 here or an implied 1. Okay? Yep. And that's all.
That's it?
That's it.
Okay, but how can
No, because they're not like terms. When you add, they have to be like terms. When you you can multiply anything together, but when you add, they have to be like terms. Because since this has got an exponent of 5 and this one a 3, they're not like terms, so you can't combine them. Make it even harder. Y'all ready? No, this is still pretty easy because it's just one term on the outside, okay? There's not more than one there. So as I multiply this out, what do? Distribute. I just distribute. All right, so to the first one. 2x, that's right, 2x, and then I add those exponents. 2 plus 3 is 5. Plus, go to the next one. That's right. 6x to the what? 4th. Good job. And again, minus, because you got to watch that sign. 4, 3. Great job, y'all. And then 2x squared times 5. 10x to the second.
So the exponent is not.
You keep the x from that you're multiplying by. Go ahead, Samara.
So you change it into a.
You just multiply the exponent. I mean, equivalent.
Okay, so the number on the outside, that exponent like
Adds to the exponents on the inside, yeah. Yeah.
If the exponents weren't in that order from biggest to smallest, would you have to do it to?
You would, and you do it whenever you got done.
Yeah.
Arranging. Did y'all hear the question? If the exponents weren't in order, you would, at your next step, you'd want to make sure they were in order because you want everything in standard form, from biggest exponent down to smallest. Good questions, y'all.
Okay, so do you just do like?
Wait, yo.
Okay?
How do we do this?
Okay.
Wait,
Why are y'all talking?
we're at 3.
Because, why not?
There ain't no because. It's sorry, Miss McGee.
Is it one?
But you'll be sorry because.
All right. I told you we were multiplying polynomials, and so we shall.
Oh, I thought she was doing the negative.
All right. This one's a little different. You've actually done one like this before. Yeah. All right, so this one, some of you might have learned FOIL before. Have any of you ever learned FOIL? We've talked about that in here before. All right, so what you have to do whenever you multiply two things like this, okay? You have to start with the first term in the first one, okay? And it needs to distribute to everything in the second set of parentheses. Once you do that, then you'll do the second term. So essentially, every term, remember we talked about what a term is, every term in the first parentheses distributes to every term in the second. Okay, so you see that I circled the first one. That's how I generally do it to keep up with which ones I have distributed and which ones I have not. Okay, so looking at this one, let's start with the first term and let's distribute it through. What is x times 3x? 3x squared. Why is that 3x squared? You add the exponents and each one of them has a 1. 1 plus 1 is dos. All right. Close. Look. Distribute it through. What is x times 2?
2x.
2x is positive here. Okay. Has that first term distributed to everything? Yes. So I will usually mark it out so that I don't get confused as I'm multiplying. Okay. And then you're exactly right, Aaliyah. Then you go to the next term. Okay. But you got to watch those signs with it. Yep. And this term is also going to distribute. Every term in the first distributes through. Okay. So now I have negative, you're right, 12x. Oh, sorry. I thought you said 12. And it goes to the last one also. So what's negative 4 times 2? Now, this one has an extra step in here. Yeah, somebody said it. It has like terms, so you always want to, just like if you're not in standard form, once you get multiply, you want to put it in standard form. If it's not simplified, you want to simplify it. So you want to combine like terms after you multiply. So looking at this one, does it have like terms? What are the like terms?
2x.
Good job. What do you get when you combine them?
3x squared minus 2.
3.
Squared minus 10.
That's right. These are my two like terms, right? 2 and negative 12 give me negative 10, and the minus 8 is still there. So there's my final answer. What you think? Let's do another one. Let's do at least one more together before y'all start on that.
Okay.
Let's say I have, I'm going to change your variable up here, b squared plus 6b minus 7. This one already looks a little different. Why? What's that called? That first one called? 3 pieces. It's called what? Trinomial. I got a trinomial times a what? Close. Binomial. All right. I'm still distributing. When I multiply like this with these parentheses, everyone in the first distributes through. Okay? All right, so circle the first. What are we going to start with? That is exactly right. Distribute it through. What is b squared times 3b?
3b.
That's right. 3b to the third. Remember, there's a little 1 here. It's not written, but it's implied. What is...
It's not a 1 times b.
Yeah, but 1 times 3 is 3. Remember, multiply the numbers in front and add the exponents. All right? B squared times negative 4 is what? Negative 4b squared. Am I done with that term?
Yes.
Yes. So I'm going to mark it out because I'm done with that one. I switched colors here so you can see so it keeps it. All right, now what's being distributed? 6b. Remember, there's an imaginary 1 on this b, right?
I thought it was 16 too.
18b squared.
So 18b to the second power. Then what? That's right. Negative 24b. Okay. Because, yep, 6 times negative 4. I'll get to it. I got to do each one of these terms. I have to take it and distribute it. Every term, I started with b squared. Okay? And it distributed. Once I was done with that, Then I took 6b and it distributed. Right? That's how I got the two green numbers. Now I'm done with that. Now I get to the -7. This one just had an extra step in there. The bigger the polynomials, the more steps you have. All right. -21b. -7 times -4 plus 28. You like this, don't you, Aaliyah? I see you smiling. Once you get it and it clicks, it's easy. Well, simplify it, right? If you have any like terms, you need to combine them. So the powers of 3 are good, right? All right, I'm done with that. I generally mark out as I go. It just helps me keep up with everything. All right, powers of 2.
14b3.
I have -4 and +18 give me +14b squared. Notice the difference when I'm adding versus multiplying, right? All right, so I'm done with these two. Now my b's here.
35.
That's right, the 28 it's a lot. How do I know I'm done?
How is 35?
How did he get
What?
It's 45. 2.
Oh, it is. I'm sorry.
Yeah.
I'm just listening to y'all.
It's 40, you said 45.
I'm sorry. It's 45. There you go. All right. Yes or no? Tell me what you think.
Yeah.